Okay, so I'm making this video about inequalities and interval notation and set builder notation. And so you might be given something that says this kind of statement, and they want you to graph it on a number line, and then they want you to write an interval notation. Now, what they started with, when you see this brackets written like this is called set builder notation. And the bracket part of it, this is making a statement. If you wrote the statement in English, it would say the set of numbers. And then it says this part, for x, the set of numbers for x, that part is referenced by these brackets, and the x, that part means the set of numbers for x. And then that straight up and down line makes this statement right there. It means such that, so the set of numbers for x such that, so that's this line, such that, and then they're going to give you the rules. What numbers can work for x? And so that's the really important part. That's the part we're looking at, is the part that comes after that line. This right here is what we wanted to know. This is the rules for the numbers. So in this case, it's saying x is less than 3. So they could have just given it to us like this, but formal sentence in math language is written in this set builder notation. The set of numbers for x such that x is less than 3 is how you read that. So what we want to do is first graph it. So we're just taking out that part that's to the right of that line. That's the part we need. So I need to show on a number line all the numbers that work for x, that make this statement true. And so one of the ways that I think make it easier to know exactly what to do is to put some numbers in for x and ask if the statement is true. So whatever number they give us, that's the starting point. So we're going to start at 3. So right here is going to be our starting point, but we need to know whether we're pointing to the left or to the right. So I would suggest, if you're not really sure, and I really stink at reading these, so I like to substitute one of the values in for x. And it doesn't matter what value. Like I just kind of always put 0 in, as long as my number here isn't 0. 0 makes it kind of easy. So if I put in there, if I said 0 and I wrote it the way the problem shows, my question is this a true statement or not? Okay, and for me, the arrow, how I read the arrow is tiny point should be going towards the tiniest number. So the point here, is this tinier than this? And it is, so it is true. And I always say, well then, you're going to point to the truth. Okay, so that means starting at the 3, I'm going to point to 0 because it made a truthful statement. And that means everything in that direction is true. Now, the question at the starting point at 3 is, should we have a solid dot there or should we have an empty circle? And the question is, how we know to do that is if there's any form of an equal sign. So if you have an equal sign or an arrow with part of an equal sign under it, like that, if it's any form of an equal sign, then you use a solid dot. If there's no form of an equal sign, then you use an empty dot because it means that this number was where you start, but you can't include this number as an answer. Because if you used 3 in that statement, well, that's not true. 3 is not tinier than 3. That's false. So 3 doesn't work, but it has to be our starting point. So we're going to make this an empty circle because our original statement did not have an equal line underneath it, part of an equal line. Now, we need to next write this in interval notation. And what they want to do is they want you to tell what is the smallest number that would work, and then what's the largest number that will work to make this true. And you have to do it smallest to largest, left to right, like on the number line. Tell the furthest left, how far would it go, and the furthest right, how far would it go. And the same thing that we set up here for if there's an equal sign or not an equal sign kind of thing, that if there's no equal sign, then we're going to use a parenthesis next to the number that we start with or end with. It will go one way or the other. If there's a equal sign where we're using a solid dot, then that uses a bracket. Notice a bracket like this is like an equal sign. It has an equal sign in it where it has this top line here and the bottom line here that like make an equal sign. That's one of the ways I get my brain to connect with that. So if there's no equal sign in with the arrow, then we're going to use a parenthesis to group this, and you'll see in a minute how that looks. But if there is a form of equal in it, then we use a bracket. So over here, the smallest number, it just points to the left forever. So the smallest number here it goes into negative infinity. It never stops. Infinity always has a parenthesis next to it. There's no stopping point. And then how far to the left does this get, or excuse me, to the right? How big does it get? Well, the biggest number that we see in this illustration is 3. Now 3 doesn't work. So, but we have to say 3. We can't just go to 2, because if we went to 2, we would be leaving out all the numbers between 2 and 3, like 2.5 and that sort of thing. So we're going all the way up to 3, but we're showing that it doesn't include 3. And again, since there's no equal here, then we're going to use a parenthesis next to it, like this. So this is our interval notation. We're going from showing the smallest number and the largest number, and that means that everything in between these also works for our statement. Let's go to another one. Here we have, let's see. Yes. So this is our set builder notation they started us with. It says a number for x such that x is bigger than or equal to -2. And so we pulled out just the important part. This was the important part we needed because it was next to this line. And so that we have x bigger than or equal to -2. Or if you want to read it as -2 is tinier than x, because tiny point towards tiny number, right? It's tinier or equal to x. So we're going to come over here to our graph, and we want to illustrate this, and we want to start at the -2, and our x values have to be bigger than, see the big open side of the arrow, but again, sometimes these can be hard to read. So let's pop a number in. Let's substitute a number in just real quick to see, are we going to point left or right? Let's pop 0 in there and see if that works. Is 0 bigger than or equal to -2? Or is -2 tinier than 0? Yes, it is. This is true. So I can point to the 0 from the -2. That's the direction I want to point, is this way. I need to know, though, at the -2, am I going to use an open circle or a solid dot there? And notice I do have a form of equals here. So that means I'm going to use a solid dot, because if it has a form of equals, then the starting point gets that solid dot. So we have illustrated that x has to be bigger than or equal to -2. Next, we want to do the interval notation. Again, we want the smallest number and the largest. So the furthest to the left that this goes is at -2. And because it's equal to -2, we are going to write a bracket here showing that equal sign. See the top line and the bottom line? Like an equal sign. So that's the smallest number, and it can be equal to it because I have a solid dot. Then we're going to look to the right, the largest number, and it goes into infinity to the right. It never stops, so we're going to put infinity here. And infinity, whether it's positive or negative, I said always gets a parenthesis. So this is the interval notation for what we illustrated as x being larger than or equal to -2. Sometimes they give us two conditions to meet. Like if I told my kid that if they wanted to go, to the mall or something, and I said, okay, you can take more than $5, but less than or equal to $10. So I gave them two boundaries, a top boundary and a bottom boundary, because I know they're going to need at least $5, to get something to drink. So don't take $2 because you won't have enough, kind of thing. But I don't want you to take a bunch of money out of my wallet. So don't take, more than $10. So that's a condition that we give, both a top and a bottom boundary. So that's what this is saying. It's saying the set of numbers for x such that x is going to be bigger than -2, but also it has to be smaller than or equal to 3. So what I do when I pull this section out of here, I write them separately. I write -2 smaller than x here, and I write x is smaller than or equal to 3 here. And you'll graph these on the graph almost like they're separate. Okay, so let's start with this one. And I want to start at the -2, but I need to know which way to point. So I'm going to put in 0 again as just a substituted in just to see if it works. Is this a true statement? Yeah, -2 is smaller or tinier than 0. So I know I need to point to the 0 from the -2. So I'm going to point in that direction. I don't know how far it's going to go, so I'll just point that way for a second. And then I'll go to the other one and plug in 0 again. Let's see if that works. Is that a true statement? Is 0 tinier or equal to 3? Yep, that's true too. So from the 3, I'm going to point to 0. So I'm going to come up here to the 3 and I'm going to point that way. So we're saying, oh, okay, from -2 to 3, these are the numbers that worked for both conditions. Now, if it was just the -2, we would have pointed clear into infinity, but these numbers past 3 don't work for the other condition. So we only want the part that overlaps, that works for both of them. So this is the line we would draw here. Now at the -2, since there's no equal sign here, at the -2 we would have an open circle. But with the 3, there is an equal sign. So we would have a solid circle here, solid dot here. So we have now illustrated that x can be bigger than -2, but it also must be smaller than or equal to 3. And so now for the interval notation, again, we go from smallest to largest, left to right. So the smallest number that's illustrated here is -2, and it has an open circle, so it's going to have a parenthesis next to it. The largest number was 3, and it has a solid dot because it had an equal sign as part of the problem. So this is our interval notation for this situation, that the numbers that start at -2 and go all the way up to 3, everything in here are solutions that make this statement true.